Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss distance between 2 points. So, let's go! The distance between 2 points is the length of the line segment joining the points. So let's say we have a number line, and on our number line we have point A and point B. So the distance, which is denoted by D, between point A and point B is the number of units between point A and point B. So therefore, we will have 1, 2, 3, 4, 5, 6, 7, 8. So the distance between point A and point B is equal to 8 units. Or you can also find the distance by getting the absolute value of the difference of A and B, which is D is equal to absolute value of A minus B. So in our example, we can have D, which is the distance, is equal to absolute value of A minus B. Since A is negative 2, we're going to replace A with negative 2 and B will be replaced by 6. Therefore, we will have D is equal to absolute value of negative 2 minus 6. Then we will have D is equal to absolute value of negative 8. Then D is equal to 8. AB is equal to 8 units. The distance between 2 points on Cartesian plane are divided into 3 categories. So the first one is the horizontal distance. So this is when your 2 points are aligned horizontally, just like point A and B on our diagram. If the distance that you're looking for is horizontal distance, you can easily find the distance by getting the absolute value of x sub 1 minus x sub 2. Then the next one is the vertical distance. So it happens when your 2 points are aligned vertically, just like point B and point C on our diagram. If you're looking for the vertical distance, you can just simply get the distance is equal to absolute value of y sub 1 minus y sub 2. Then the last one is a diagonal distance. If 2 points are aligned diagonally, then you will have to find the diagonal distance. And to do that, we're going to use the Pythagorean theorem, which is c squared equals a squared plus b squared. Okay, so how to use the formula? So let's have a Cartesian plane, and let's have point A with coordinates 2, 2, and point B with coordinates 6, 2. So suppose you want to find the distance of AB or solve for AB. So to do that, you identify first if it is horizontal, diagonal, or vertical. And on this one, these points are horizontally aligned. So therefore, we will have the formula for horizontal distance, which is D is equal to the absolute value of x sub 1 minus x sub 2. Since on our formula, we need x sub 1 and x sub 2, we're going to assign our x coordinates on our points as x sub 1 and x sub 2. So therefore, we will have 2 as x sub 1 and 6 as our x sub 2. Then we're going to replace x sub 1 and x sub 2 with the values that we assigned. So we will have this equal to absolute value of 2 minus 6. Then we will have this equal to absolute value of negative 4, which is positive 4. So therefore, AB is equal to 4 units. Now let's have another point. Let's have point C with coordinates 6, 5. So suppose you want to solve for the distance between BC, then you will have the segment joining B and C, which is actually a vertical distance. So since it is vertical distance, our formula will be D is equal to absolute value of y sub 1 minus y sub 2. So we're going to assign our y sub 1 and y sub 2 on points B and C. So we will have y sub 1 is the y coordinate of point B, and y sub 2 is the y coordinate of point C. Using those values, we will have this equal to absolute value of 2 minus 5. And that will give us this equal to absolute value of negative 3, which is positive 3. So therefore, BC is equal to 3 units. Now let's solve for the distance of AC. So obviously, AC is a diagonal distance. And for the diagonal distance, we're going to use the Pythagorean theorem, which is c squared equals a squared plus b squared. And if you're going to notice on our diagram, we already formed a right triangle. So therefore, we can apply the distance formula to find our missing side. So for this one, we will have A is equal to 4, then B is equal to 3, which are the distance of AB and BC respectively. And all you have to do is to find your hypotenuse, which is our C, which is the distance of AC. So using the formula, we're going to use the values of A and B. We will have C squared is equal to 4 squared plus 3 squared. Simplifying this further, we will have C squared equals 16 plus 9. And that will give you C squared equals 25. Getting the square root of both sides, we will have C is equal to 5. So therefore, our AC is equal to 5 units. Okay, so let's have another example. So let's say we have a Cartesian plane and we have point A and point B. So suppose you want to solve for the distance between A and B, all you have to do first is to identify if it is horizontal, diagonal, or vertical. And for this one, it is vertical distance. Therefore, our formula will be d is equal to y sub 1 minus y sub 2. So we're going to assign the y sub 1 and y sub 2 on our points. So we will have y sub 1 is the y-coordinate of A, and y sub 2 is the y-coordinate of B. Then using these values, we're going to have d is equal to absolute value of 1 minus 7, which is equal to absolute value of negative 6, and that will give you d is equal to 6. AB is equal to 6 units. Let's have another one. So let's have point R with coordinates negative 3, 3, and point S with coordinates A3. Then solve for distance between point R and point S. So point R and point S will give you our horizontal distance. So therefore, our formula is d is equal to x sub 1 minus x sub 2. Then we're going to assign the x sub 1 and x sub 2 on the x coordinates of our points. So let's have x sub 1 is the x coordinate of R, x sub 2 is the x coordinate of S. Then we're going to use those points to replace x sub 1 and x sub 2. So we will have d is equal to absolute value of negative 3 minus 8. Then that will give us absolute value of negative 11, which is positive 11. So therefore, RS is equal to 11 units. Okay, so let's have our last example. So let's have point M with coordinates 5, negative 2, and point N with coordinates negative 2, 5. So if you want to solve for the distance of MN, so you're going to look for the diagonal distance. So since it is diagonal distance, we're going to use the Pythagorean theorem c squared equals a squared plus b squared. And again, since on our figure we do not have right triangle, we're going to add 2 more lines to make a right triangle. After this, we're going to solve for the distance of your legs. So first, the horizontal distance will give you 7 units. Then the vertical distance will give you also 7 units. After this, we're going to use those values to solve for our c. So c squared is equal to 7 squared plus 7 squared. C squared is equal to 49 plus 49. Then that will give you c squared equals 98. Get the square root of both sides. Since 98 is not a perfect square, we're just going to simplify it. We're going to express it as product of 49 times 2. Since 49 is a perfect square and we can get the square root of 49. And that will give us c is equal to 7 square root of 2. So mn is equal to 7 square root of 2 units. Okay, so that's it. Thank you for watching and hope you have learned something from this video.